Okay, so today we're going to continue with 3.8. Now, part one would be considered our easy solving of radicals. And so today we're going to bump it up a little bit. So the first one we have is the square root of 13 minus x equals x minus 1. Now, if you remember from our first lesson, we know that the radical needs to be by itself, which it is in this problem. But in order to solve, because we want to solve for the x, and currently x is under the radical, we need to square both sides, okay? So I'm going to square both sides, and that actually means square both sides. Don't write parentheses around the entire equation, both sides, okay? Now, when you square a radical, or sorry, when you square a radical or square a square root, to be more specific, not just a radical, you remain with the radicands. We get 13 minus x equals. Now, what happens on the right side? We have a binomial squared. So that means I cannot just simply distribute my square. I actually need to write it twice and FOIL. Again, you cannot distribute the square. You must write it twice and try and there we go. Sorry, it was just a little fuzzy. Okay, so now we're going to FOIL on the right side. The left side just hangs out. So we have first term, outside term, inside term, and last term. Combine like terms. We get x squared minus 2x plus 1. Now, if you feel comfortable, you can go straight here. You do not have to show your actual FOIL method if you can do it in your head and combine that middle term on your own. Now, what you should notice at this point is that we have x's. We also have x squared. Now, we did a lot of work with x squareds before. Keep in mind that if you have an x squared, that means you have a quadratic, okay? And in order to solve a quadratic, what we would normally do is factor it, okay? But we can't factor it until it's set equal to 0. So there's a lot of things that we got to do before we can go ahead and solve this problem. So a little bit of a information, sorry, little hair. Okay, so when you have to solve a quadratic, okay, when you have an x squared, okay, you need to set it equal to 0 and factor. Okay, so again, in order for us to solve, because we have a quadratic, we have to set equal to 0 and factor. So in order to do that, you want to keep your x squared positive. So we're going to move the left side to the right. So I'm going to subtract 13. And I'm going to add x. I'm going to line that up so that I can see what is going on. So I have 0 equals x squared minus x minus 12. Okay, so now it's set equal to 0. We want to factor. Okay, so we have a basic trinomial. So we have two binomials. It's going to go into x and x. We are multiplying to a negative number, so I know I have to have a positive and a negative. And we want a difference of negative 1. So factors of negative 12 that add to negative 1. So that would be 4 and 3. In order for it to be negative, we would need it to be, sorry, a negative 1, we'd need it to be negative 4 and positive 3. Okay, so we've done the factoring bit. But how do we actually solve for x? Okay, so you're going to set each quantity equal to 0 and solve. So I'm going to set x plus 3 equal to 0, and I'm going to set x minus 4 equal to 0. Okay, and solve, meaning what does x equal? Well, if I'm going to subtract 3, x would equal negative 3, and if I add 4, x would equal 4. So we have two options. Now we remember from our first lesson that we do need to check our work. So when checking, okay, square root, going back to the original problem, 13 minus -3 equals -3 minus 1. Okay, so we're going to do some of this in our head. If you need to write it out, please write it out. 13 minus -3. So minus a negative is positive. So 13 plus 3 would be 16. Square root of 16 is 4. Okay, and that equals -3 minus 1, which is -4, which isn't true. And we'll come back to that in just a sec. What does that mean for us? Let's try the other one. 13 minus 4 equals 4 minus 1. Okay, so 13 minus 4 is 9. Square root of 9 is 3. And 4 minus 1 is 3. Okay, so that one works. Okay, check mark. Okay. Some people like to put an X on the ones that don't work. So what does that mean? That means that we know x equals 4 is a solution. We also know that x equals -3, I'm going to put an X through it, is what we refer to as an extraneous solution. An extraneous solution. So what does that mean? Essentially, it's a solution that we find while solving, but it doesn't actually work. So on a test, if I said what was an extraneous solution, you would list it. If not, you would just list x equals 4, and then in the work, I would be able to see you did in fact solve for -3, and you checked it to see it was wrong. So you would get the points to see that. Okay, if you just have 4 and don't have any work to prove that -3 didn't work, then something obviously went wrong. So it is an extraneous solution. It's not technically a part of the final solution, but it is part of the correct work. Okay, so that is how we would do number 7. So technically the only answer is 4. Okay, let's go ahead and try number 8. Okay. Number 8 is x minus square root of 4 minus 3x, which is equal to -8. Okay, now what you may notice is that we first off don't have the radical by itself. We also have a negative radical. Now, is it the end of the world if it's negative? No, but it's helpful if it's positive. So rather than subtracting the 8 to the other side, which would be pretty easy, right? It's just one step. Instead, I'm going to add 8 to the left, and I'm going to add my radical to the, I'm going to add my 8 to the left, add my radical to the right. Not really sure what I said before that. And that way I can, 1, isolate my radical, and 2, make my radical positive. So I'm going to add 8, and I'm going to add my radical. That way I'm left with x plus 8 equals the square root of 4 minus 3x. Okay, now we have a situation where it looks more similar to the beginning of number 7, where we have a radical by itself. We have something on the left. Obviously, they're swapped from the original one, but that doesn't matter. At the end of the day, we know that we have to square both sides. And because we do similar problems, you should notice, because we're squaring a binomial, that means we have to FOIL it. And FOIL means writing it twice. And on the right side, that would mean we're left with just the radicand, because squaring a square root cancels them out. Okay, I'm going to go ahead and FOIL that out. X squared plus 8x plus 8x plus 64. Combine like terms. We get x squared plus 16x plus 64 equals 4 minus 3x. Okay, now again, we have an x squared and we have x's, so that means we're going to have quadratic. So we're going to set it equal to 0. And again, x squared being positive makes our life easier. So I'm going to subtract 4. I'm going to add 3x. X squared plus 19x plus 60 equals 0. Okay. Now we want to factor. So we have x and x. Okay, we're multiplying to a positive. So it could either be positives or negatives, but we're adding to a positive. So we do know that they should both be positive. Now we want factors of 60 that add to 19. Okay, so I'm going to give you a second to think about what those could be. Okay, hopefully you came up with the right ones. So we should have positive 15 and positive 4. Now remember, it doesn't matter what order you wrote those in, as long as you have positive 15 and positive 4. So I'm going to set each of those equal to 0 and solve. So I get x equals negative 15 and x equals negative 4. Okay, now we need to go ahead and check. So I'm going to check with the first one. We got negative 15 minus the square root of 4 minus 3 times negative 15 equals negative 8. Okay. And obviously we're trying to figure this out. Oh, sorry. Let me move my screen. Move my thing there. There we go. Okay, let's do some mental math. So negative 3 times negative 15 is positive 45. 45 plus 4 is 49. Square root of 49 is 7. Negative 15 minus 7 is negative 22, which does not equal negative 8. Okay, so that is extraneous. Let's check if negative 4 works. That was a very long radical, unnecessary. But, you know, at the end of the day, I would just want to make sure it's long enough, but not that long for the radical. Then we have negative 3 times negative 4, which is 12. 12 plus 4 is 16. Square root of 16 is 4. Negative 4 minus 4 is negative 8, which equals negative 8. So therefore, negative 4 is our solution. Okay, now again, if you can't do the mental math like I did, totally fine, just write it down. Okay, but it's the same process. I'm just doing it a little bit quicker in my brain because I know some of you can. So I want to give those opportunities for those that can do it a little bit faster to do so. But if you need to write it out, just like if you needed to write this out, which wasn't necessary, that's okay. All right, let's do some reminders before we do number 9. So just kind of a step-by-step of what we've been doing for 7 and 8. So, not remainder, reminder. Let's try that again. Okay, reminder. Okay, so first thing we want to do is isolate the radical. That is our first step, okay? And obviously bonus points if it's positive. Then you're going to square both sides. Okay, we did that. Okay, at this point, there's a few things that could happen. At this point currently, that means you're expanding, expand, or FOIL / simplify. Okay. Once you've done that, then you need to get it equal to 0 and factor. And then you're going to set each quantity equal to 0. Well, I keep trying to combine my words when I'm writing them down. So set each quantity equal to 0. Solve. And check your answers. Okay, so these are the basic steps that we are following. Isolate the radical, square both sides, expand / FOIL, simplify it, get equal to 0, factor it, set each quantity equal to 0 that you factored, solve for that variable, and check your work. Okay, I know I said simple steps, but obviously those steps do take some work. Okay, so before we do a number 9, if you feel like you are good to go ahead and pause the video and try it all on your own. If not, we can do it together again. Number 9, which is 2x plus the square root of x plus 1 equals 8. I don't know what happens with my square roots sometimes. They just kind of go a little crazy. Or, I'm crazy. One of the two. Probably both are true. Okay. So again, if you feel comfortable, go ahead and pause at this point and you can try it on your own. If not, hang tight and we'll do it together. Okay, let's try this one out. So remember, our first step is to isolate the radicals. So I'm going to subtract 2x to the other side. So I get square root of x plus 1 equals. Now, because we're minusing, technically we could put negative 2x plus 8, but typically it goes a lot easier if you just put the subtraction sign second. So 8 minus 2x. And we already know we're going to square both sides now, or we should know. And so at this point, you're going to be squaring things, so it's a little bit easier just to have that negative second. So we're going to square both sides. So I have x plus 1 equals 8 minus 2x times 8 minus 2x. We expanded it. Then I'm going to FOIL. So I have 64 minus 16x minus 16x plus 4x squared. Combine like terms and simplify. Get 64 minus 32x plus 4x squared. Okay, now we need to get it equal to 0. So I'm going to subtract x, subtract 1. So 0 equals, and I'm going to put it in the right order when I do this, 4x squared minus 33x plus 63. Okay, so I just put it in proper standard form. Now we need a factor. Now, don't forget your 0. We want to factor. Now, keep in mind, there's going to be lots of different options for factoring. Okay, we have 63 that has a few different options, and we have 4 that has a couple different options. So at this point, go ahead and pause it and see if you can figure that one out. Okay, what you should end up with is 4x minus 21 and x minus 3. Right, so I'm going to set both of those equal to 0. So I'm going to get 4x equals 21 divided by 4. I get x equals 21 fourths, or I get x equals 3. Okay, and I'm going to check my work. So I have 2 times 21 fourths plus 21 fourths plus 1. There goes that radical again. Equals 8. I'm trying to see if that works. Now, when you have fractions similar to a fraction like this, that's a little bit, let's say, more difficult than 1/2 or 3/4 or something like that, perfectly fine to use your calculator, okay? And if you use your calculator, or if you use the calculator in your brain, no judgment at this point. Sometimes you just don't have the energy to try and do it mentally, because at the end of the day, sometimes it's going to just be faster in the calculator. Okay, you should get 13, which is not equal to 8. Okay, let's try the other one, which is 3. Okay, now in this case, it would take longer to use your calculator than to just do this mentally, because it's an easy number. Okay, that's what I was referring to. So 3 plus 1 is 4. Square root of 4 is 2. 2 times 3 is 6. 6 plus 4 let's try that again. 6 plus 2 is 8. 8 equals 8. So x equals 3 is correct. 21/4 is extraneous. Okay, we're going to go ahead and stop this video here and do the next set of problems in the next video. Okay, see you there.